Okay, so for 7-5, we're looking at properties in a triangle. All right, sorry, not properties, proportions. My bad. Proportions and triangles. So 7-5.
Recording a video, Mrs. Rizak.
Yeah. Proportions in triangles. Now, we've done proportions in triangles already. We've talked about similar figures, right? That was all before we even went on break. We have similar figures. We know that when we have two similar triangles, we can set up proportions and so on. But now, what we're focusing on is some overlapping triangles, really. So, if we have a triangle, great. Now, if you have a triangle with two parallel lines drawn in, that's enough to know we have two similar triangles. So if I was to label this A, B, C, D, E, I could say that triangle A, B, C is similar to triangle what? So A, B, C, what? A, D, E. Now, how do we know how they line up? Again, the corresponding parts have to go together. But how do you know which parts are corresponding? Well, you have to use some of your properties. We have parallel lines. If you're dealing with parallel lines tell you that there are some certain angle relationships that must be true. So in here, there are certain angles that must be congruent. Based on these two being parallel lines, if this is a transversal, the angle B in the big triangle and angle D in the little triangle are in corresponding positions and therefore must be congruent. If you look at the other side, angle C and angle E in the little triangle are in corresponding positions, so they must be congruent. If you want to go as far as saying angle A is in both triangles, it's congruent to itself, so again, it must be congruent. Now, you have all three angles. All you need is two to prove that two triangles are similar. But we've marked all three angles as being congruent. So we have this little triangle and the big triangle must be similar, right? So, now that we know that we have triangles that are similar, we can use similar triangles to find different missing lengths if we're given some lengths. So I'm going to add some numbers in here now. I'm still using the same figure, but I'm going to go ahead and put in a few values. So the length of AE here is going to be 3. The length of EC is going to be 6. The length of AD is unknown. It's going to be Y. The length of DB is 12. The length of ED is unknown. It's going to be X. And the length of CB is going to be 15.
If they're all congruent, then shouldn't they be the same? Shouldn't X be?
No, again, I didn't say anything about... Hold on, slow down. So, I didn't say anything about the pieces being congruent, right? The angles are congruent. So again, the sides must be proportional. Now, I want to solve for X first, all right? So let's take a look at X. In order to solve for X, we know we have to use X in a proportion. All right, X and 15, those should go together because those are in the same corresponding position for the triangles. Now, what do we set them equal to?
3 over 6.
All right, does everybody agree 3 over 6?
Yes.
Wait, oh, yes.
All right, so let's just double check because, again, anytime we write a proportion, anytime at all that we write a proportion, we should have something in common horizontally across the proportion and vertically across the proportion. Where did you come from? Oh, okay. I thought you randomly walked to the bathroom or something.
Well, then I went to the bathroom after. And then I came here.
Okay, all right.
Turning in.
Make sure you sign in and get caught up. Anyway, for our proportion, again, horizontally, there must be something common. Vertically, there must be something common. So we got x and 15. All right, they are in the same corresponding side. Therefore, that looks good. 3 and 6, they're on the same corresponding side. That looks pretty good. 6. No, actually, let's do the top. X and 3. X and 3 both came from the little triangle. That looks good. And then 6 and 15. Are those both from the big triangle then?
No, they're not. You would have to have 3 plus 6, which would be 9. So 9.
So 6 is actually wrong because 6 is not part of the big triangle. It's only part of that side. We need the entire side of that big triangle. So we need to combine those two. This entire side of the big triangle is 9. So this is actually 9. So again, because again, I want to make sure that you're checking your work and make sure that you're reasoning it out. Is my proportion correct? Because it's easy to make a mistake like that. And the mistake that I showed, that's the most common mistake. And I can guarantee that a lot of you guys not paying attention will make that mistake on the next test. Because that's the mistake that always happens. For this side here, we're using the entire triangle no matter what. There is no shortcut when we're talking about finding this side that's not being split by the parallel lines. So, now that we have a correct proportion, we can cross multiply and solve. So we got 9 times x is 9x. 3 times 15 is going to be 45. Divide by 9, and x is 5. Now, we have x. We need d. So, by the same idea here...
So we need D?
Oh, sorry, not d, y. I looked at the wrong letter. So we need y. Now, for y... Again, we could do the same exact idea. Again, this entire side of the triangle is going to be, well, we only had one of the two numbers. But we can write this as an expression. So, not 12y, careful. No. So we have to add them. So again, they're not like terms. We can't actually combine them. They're going to be two separate terms. So we're adding the y and the 12. So either y plus 12 or 12 plus y. Either way is fine. Now, guys, ladies. Now, we have this side. We're solving for y, so we're going to have to use those parts. So start off with the first fraction. We definitely have y from the little triangle. We have y plus 12 from the big triangle. For the other side of this, now we have a choice, because in the last problem, we just solved for x. X was 5. So now that we know what x is, we could choose to either use 5 and 15 or 3 and 6. Wait, can we use 3 and 6?
No.
So it would be 3 and 9, the way I have this set up, right? So 3 and 9. Again, I'm going with those two numbers just because they're the original ones that we were given at the beginning. So now that we have those, we can cross multiply and solve. If you want to, you could even simplify. I'm not going to go through the step of simplifying right now. Let's just go ahead and cross multiply and solve. So 9 times y is 9y. 3 times y plus 12. Again, you're going to have to distribute that 3 to both parts. So you're going to end up with 3y plus 36. Now, we still have a couple steps to do. We got to get this y over to the same side. So you're going to have to subtract off that 3y from both sides. So that gives you 6y equals 36. Then, y equals 6, because if we divide off 6, the other value is 6.
Use because 3 is half of 6, so 6 is half of 6.
All right, so you're bringing me to the point that I want to make here. So, all right, Josh recognized something, and this is what I want you to recognize from this. When you look at the overall figure now, we have all the numbers, right? All the numbers are plugged into this figure. There's a relationship between some of these numbers other than what we already saw. 6 is half of 12. 3 was half of 6. There is a ratio that you can use here to make this last problem we did a whole lot easier. These two sides will always be proportional because of the parallel line. All right? Shh. Hey, guys. So the main idea in this entire section all has to do with the fact that we have parallel lines. So I know this section is called proportions and triangles. It should really be called proportions with parallel lines, because that's the main focus. If you have a parallel line in a triangle, it's splitting those two sides proportionally. If you have parallel lines splitting any other lines, it's also splitting them proportionally. So we're going to write down one of the theorems from this section, which is based off the idea of the triangle. So now your book, if you want to remember it by the name, you're more than welcome to. I think your book makes up this name because I've never heard it before. Side splitter theorem. Okay, that's just what the book calls it. I've never seen that in any other book, but you know, I'm just calling it theorem 7-5. But if you want to call it side splitter theorem, I'll know what you're talking about. So this is the statement. Now I'm going to read it out first, and then I'm going to write it. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides these sides proportionally. All right? So again, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides these sides proportionally. Alright, kind of ran out of room at the end. Let me just fix that.
Is that after the triangle? Is that a plus or a 4?
Alright, so that's an and.
Oh, what the heck?
It's been the same and symbol all year long. So,
looks like a
again, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides these sides proportionally. So let's draw an image to go with this. If I drew a triangle, again, I'm going to draw it very similar to what I had up at the top. And I draw in a parallel line. Now, I'm only going to label the lengths of the pieces to make this a little bit easier. But if we had X, Y, W, and Z, essentially an easy way to remember what to do here, we have our parallel line that's been drawn in. Use that parallel line so that you're kind of treating it as your fraction bar. Extend it out to the sides. That's going to be your proportion. X over Y equals W over Z. Alright? So again, X over Y equals W over Z. That would be a good proportion for that figure. Here? So what I said was, an easy way to remember this is take that parallel line that's drawn into your triangle, extend it out, and it's like a fraction bar. And then we have our proportion already. Those two equal to those two. Now, I will. Trust me. These are going to run out of ink. I've already went through. This is, I think, my third pack. See, there's one empty one. They write nice and they erase easy. I love them. They're like the best pen for like doing any of this, because I can correct things. I don't have to scribble it out. You didn't buy yourself a pack?
I also need to buy these presents. I will wipe them for myself. And I like this one. I need you. I always do my
See, I like these pens too, so I only use them like for usually drawing the main figure at the beginning and not for labeling them.
Is that uniform line? Or is it like an or is it like
Can you check my
Hold on. Oh, those are my second favorite pens. The only problem is I usually write on my and get like ink all over my hands with them. But all right, okay, I'll check that out for you in just a second. All right, or actually, you have it right there. I'll take it. Thank you. Now, on here. So, I drew 3 parallel lines. This is essentially the same idea. It doesn't matter, guys, ladies, gentlemen, listen. It does not matter how many parallel lines I draw. I could have drawn like 10 parallel lines. And then as long as you set up a proportion so that you are combining parts from within the same parallel lines, you'd have a correct proportion. So, an example here would be if I label this as A, B, C, and D. Same way that I use my parallel line as my fraction bar over there. Fraction, equal. A over B equals C over D.
When will we find out our grades for the exam thingy?
They were posted on last quarter. So like if you look at your... Oh, well, she has exam.
Oh, what about the quiz we took last?
Exam was posted on last quarter. Quiz, I haven't posted yet. I haven't finished grading them. No, I don't know. I haven't finished grading
So
them.
is it on
All
every
right,
scale?
but from what I saw when people were terminating this period did the best.
Is it still on SB, the exam?
Hmm?
Is the exam grade still on SB?
Yeah, if you go into recent classes, then you'll see it in there. All right. Any questions there before I do the last thing? All right, here we go. So, one final topic for this section. This last theorem is called triangle angle bisector theorem. So again, triangle angle bisector theorem. Now, for triangle angle bisector theorem, guys, ladies, again, it's essentially what it sounds like. If you draw an angle bisector into a triangle, there's a theorem about it. And it has to do with similarity, or proportions, and setting up a proportion to solve for something. So, for triangle angle bisector theorem, I'm going to read it off first. It says, if a ray bisects an angle of a triangle, then it divides the opposite side proportionally with their adjacent sides. Now, that's the short version, because some books write it that way. Our current textbook writes it a little bit different, and it's a little more long-winded. I like this version because there's more than one correct way to write a proportion when using this theorem. Again, anytime you set up a proportion, there's always at least 4 ways to set it up. So,
Okay, Joshua from the future.
on here,
And from the past.
if a ray bisects an angle of a triangle, then it divides the opposite side proportionally. Proportionally
Wait, are you posting this tonight, Mr. Bizet?
with their adjacent sides. So, what that means is that if I draw a triangle, and it can be any triangle, it doesn't matter what it looks like. If you draw in an angle bisector, that angle bisector splits the opposite side, not congruently. Again, this does not pass through the midpoint. It splits it so that these two pieces are proportional to their adjacent sides. So, if I label this as A, B, C, and D, Again, you can kind of treat this angle bisector the same way I use that parallel line in the last two problems. It's making your proportion for you. These two sides are equal to those two sides like that. So you can either say A over B is equal to C over D, or the other way you could look at this is use the parts that are on the same side of the angle bisector. So that A over C equals B over D. Again, making sure you set that proportion correctly is important. But you have to make sure that there's something similar about everything horizontally and vertically there. So both of those work. All right, both of these are options. So either of these methods, either that one or that one. Now, for your homework tonight, there's going to be a couple things that I'm asking you to do. So again, we went over the basic notes for this section. There is one property that kind of gets mixed in with this that I'm going to post in the notes as well. So like online tonight, I'm going to give you guys a couple of examples, and I want you to copy the examples because I'm not, again, we did most of the notes in class here. So I'm going to give you a couple of examples that I want you to do. And then I'm also going to give you guys a couple problems that I want you to do as well. So we're going to do some examples and some problems for your assignment tonight. Now, the problems come from your pages that you ripped out. So make sure you bring those pages home with you, the pages that you ripped out. Or again, you could use the textbook pages. So I'm giving you guys an assignment tonight. I'm going to post it on Edsby. All right. So make sure you bring those pages home with you. And if you don't bring them home with you, then you can use your textbook pages, or you can use the online textbook. Again, there's several other options there as well. But again, I'm talking about those from last week, or from last week I had you rip those out. Now, other things that I need to talk about.